Now we're going to discuss a concept called the dot product of vectors. So here I have an illustration for you. So suppose you're given two vectors. So U has these components, it's in 3-dimension, and V has these components. So U dot, so this is what we mean by dot, it's a multiplication. U dot V is equal to, you pretty much multiply each corresponding component and add them up. That's how we're defining the dot product of two vectors. You can also apply the same thing in 2-dimension, except you don't get the third component of that particular vector. There's another way you can define this. For example, if you know the angle between these two vectors, then our dot product can be rewritten as the following. So U dot V is equal to the magnitude of vector U times the magnitude of vector V times cosine theta. This is also a very nice way of redefining the dot product, because this will enable you to find the angle or theta between the two vectors U and V. So for this particular example, we're given two vectors in 3-dimension. So here's U, here's vector V, and we want to find U dot V. So by definition, we're going to apply the first definition. So we know U dot V is equal to, so we multiply its x component, so that will be U1 V1 plus the y component U2 V2 plus the z component U3 V3. Now if you want, you can write each vector component wise. For example, this vector can be written as, so you can write this vector U as, so its x component is I, well I is missing, which means it's going to be 0, y is j, so that's going to be 5, and z is k, so that's -3. Those were the coefficients. And v, you can also write component-wise, so this will be the x, y, and z, so they're all 1. So we can write v as 1, 1, 1, so just like this. Now let's do the dot product. So we're gonna take the x component, multiply them. So we'll do 0 times 1 plus, now take the y components, 5 and 1, multiply them. So that'll be 5 times 1. And now we take the last components, -3 and 1, we multiply them. So that's -3 times 1. So this will give us 5 times 1, that was 5, and then -3 times 1, that's -3. So this is 2. So the dot product between the vectors U and V is 2. It's a number. So as you can see, when you dot two vectors, you get a scalar. You do not get a vector. So make sure you keep that in mind as you proceed with the dot product.